the sniffling. All right, now it's running. So, all right, so transformations of quadratics is where we're at today. Like I said, it's going to be a little bit of a review over some stuff. So let's quickly blitz through that, and then we can talk a little bit about, like I said, we're going to take it a little step further here. So a quadratic, what's the parent function for a quadratic?
X squared.
X squared. F of x equals x squared. All right. So, and there are three different types of transformations that we talked about before. There's translations, or moving it up, down, left, and right. Reflections, reflecting over the x or y axis. And stretches and shrinks, both vertically and horizontally. Okay? So, let's jump back into translations for a second. All right, so for a translation, there are two different kinds. There are horizontal and there are vertical. And that's a k. It's not an x. So I got x squared plus k. And in this case, k is just going to be some number. Okay, so if it looks like this, is that a horizontal or a vertical type translation? Vertical, right. Okay, this is an up and down. So depending on the value of k, it might go up, it might go down. Yep.
Is k kind of like b in y equals mx plus b?
Yeah, it's kind of that same. One letter because it doesn't always mean exactly the same thing. There depends on how you look at it. In y equals mx plus b, b is referring to a y-intercept. We use a b for a y-intercept. Written like this, yeah, that is technically a y-intercept, but if I move or stretch this thing around a little bit more and do some other things with it, that k might not necessarily stay a y-intercept, so we don't use the same letter for that. K in general always refers to some kind of translation up or down, by the way. So yeah, it does. So there's that. But all right, so depending on the k, if k is greater than 0, what kind of a translation do we have? It's going to go up, right. And if k is less than 0, it will go down. And obvious question, what if it's 0 right on the nose? Nothing. Stays the same, right? Okay. It's not infinite, but it just stays the same. All right, so that's the vertical. Okay, so these are vertical type translations. The horizontal translations look like this. Yeah, they're inside parentheses, and then you square it. Okay, and so with horizontal ones, and by the way, H is always used to describe left and right. Mm-hmm. So if H is greater than 0, what direction is it going to go? It's not up and down. It's going to be left. Okay, so remember, horizontal stuff is always the opposite of what you expect, right? We talked about that before. So if it's going to be greater than 0, that means it's going to be plus some number, which actually means you're going to the left. And if it is less than 0, that means it's minus some number, and it actually goes to the right. Okay, so we did a whole bunch of these with linear functions and quadratics and absolute values, and we had to kind of try to keep straight what was going on. So two different directions with it. So I might ask you, like give you an equation and ask you what's happened, how has it been moved, or I might tell you how I want to move it, and then you have to write the equation for me. So let's do one of each. So let's say, again, I'm starting with my parent function up there, x squared. I want to move it both up 3 and left 2. So what would that look like? Yes, sir?
Parentheses x plus 2, and then 3. And then you got to square it, and then plus 3.
Got it.
Nice.
All right, makes sense, everybody? It's a plus 2 because it's going left. Again, the horizontal movement on the inside is opposite from what you expect. And then the plus 3 on the outside, vertical movement, is exactly what you would expect. Okay, so that's doing it one way. If I give you the equation, then can you take it the other direction? So if we had f of x equals x minus 1 squared plus 7, how is that one translating? Let's have somebody else this time. I like the enthusiasm, though. Yes? All right, so it's going to go to the right 1 and up 7. Okay. Feeling okay with translations in general? Those tend to be the easier ones. Okay. Let's talk reflections next then. Make sure we're still on board with that. Okay, we had two different kinds of reflections, over the x-axis or over the y-axis. Okay, so anybody remember how we do an x-axis reflection? Where does the negative go? Because remember, these are just throwing a negative in somewhere. Yes, sir?
The negative goes in front of the x.
Nope. In front of the entire equation, whatever it is. Okay? So, well, sort of. Anyway, so if it's starting out as x squared, what should it look like if I'm reflecting it over the x-axis then? Negative x squared, right? Okay. Now, an interesting thing happens with the y-axis reflection. Think about what a parabola looks like. In fact, I'll put it on here. Okay, your parent function parabola, right? Nothing special. It just looks like this. What's going to happen to that thing if I reflect it over the y-axis? It's going to look exactly the same. Okay? But our rule for reflecting over a y-axis was to replace x with negative x. Okay? Well, look at what happens to our parent function when we do that, though. It's negative x. Remember, the negative is just on the x, right? It's not on the outside. It's on the inside. Negative x squared. Well, what's negative x times negative x? Positive x squared, right? So this is really just the same thing as what we started with, right? Both equations are technically the same, and the graph the graph supports that idea, right? That if you reflect x squared around the y-axis, it's still the same thing. So the equation better be the same thing still too, right? Okay, so a reflection around the y-axis doesn't change anything for a quadratic, at least the parent function one. Okay. Now, if we scoot it around a little bit and then do that, then maybe. But for the parent function, it doesn't. So, all right. If you're just reflecting the parent function, yeah. But if you had, let's say, like, what if your parabola was starting over here somewhere, and then you reflected it around the y-axis? That would change, right? So it all depends. Did you move it first? Or is it just the parent function still sitting on 0, 0? If it's still the parent function just sitting on 0, 0, nothing changes. But if it's been scooted over and then you reflect it, that's going to make a difference. Okay? Well, the thing is, if you move it left or right first, there'd be some kind of plus something or minus something on the inside first, and then you change it to negative x. So in that case, it wouldn't just flip back to x squared because you got the other stuff in there too, right? So it would make a difference then.
Would you just put the negative in front of the x, or like, would you put it with the number that's inside the x?
Just next to the x. Just next to the x, okay? In fact, you want to do one of those real quick? I'll show you how that works. So let's say we've got f of x equals x squared. We'll start with that parent function. And then let's say I want to, first, we're going to move it right 2, and then second, we're going to reflect over the y-axis. Okay, so I'm going to do a little combination here of the translation and the reflecting and how that actually changes things up. Okay, so after I move it to the right 2, how's the equation going to change? We're just doing the first one, so just to the right 2.
X minus 2.
X minus 2 squared, right? That's after the first thing. And then after we move it, Now we reflect it. Okay? So it's just replace x with negative x, right? So negative x minus 2 squared. And that is not the same thing as x plus 2 squared. You can't just take out the negatives. Okay? That has to stay like that.
And then over the x-axis, you just put the parentheses in.
If you wanted to then take that and move it and reflect it over the x-axis,
It'd be negative times the entire equation.
right, it would just be negative all of that.
That's all you need.
The x-axis ones are easy. Yeah, it's because it's whatever you see, just throw a negative in front of it, done. Okay? The y-axis ones can be a little tricky, but as long as you can locate x and then just switch it to negative x, done. Okay? So this is the kind of stuff we're going to be doing a little bit later. Some more combination stuff like that. And the order is going to matter, too, in what we do things. So in this case, we moved it to the right 2, and then we reflected it over the y-axis. Okay? That gives you a very different graph than if we would have done it the other way around. Started with a reflection and then moved it. But we'll talk more about that later. We'll get to it. All right. Last thing, stretches and shrinks before we get into the more combination stuff here. So let's review on this a minute. There are two different kinds again, vertical versus horizontal. And depending on what kinds you have, determines where you're going to mess with the equation, right? Again, vertical stuff is outside the whole equation. Horizontal is just on the x. So we got a times x squared. And a, again, is just some number, okay? So let's say I wanted to make this a vertical stretch. What would have to be true about a to make it a vertical stretch? Somebody else this time. Tyler. Greater than 1. Yeah, good. Okay, and then what would make it a shrink? Less than 1, right. Another silly question for you. What if a was exactly 1? Nothing. You multiply by 1, what happens? Nothing, right? Stays the same. All right, so that's your vertical stretch and shrink. We also have the horizontal. Okay, again, note the difference. We're multiplying not the entire equation by a number, but just the x by a number, right? It's horizontal, so things aren't always what they seem. So what's going to make this thing a stretch? B has to be less than 1. It's the opposite. Yep. Okay, to be a stretch with a vertical, it had to be greater than 1. Stretch with a horizontal, it's less than 1.
What's the difference between a vertical and horizontal?
Vertical stretches, think about taking all the points and pulling them away from the x-axis. That would be a vertical stretch. Or compressing them towards the x-axis, that's a vertical shrink. Horizontal would be like, horizontal stretch would be pulling it away from the y-axis or pushing it towards the y-axis. Stretch versus shrink.
Wouldn't that be a horizontal shrink be
Yeah, wouldn't a horizontal shrink be
a vertical stretch?
You got it. Yes.
So why,
Yes.
why do we need to know?
Well, okay, it doesn't happen. Okay, that's only true with quadratics. And the only reason that we teach you both vertical and horizontal is because with other functions, you definitely need both. But with quadratics, you can turn one into the other, or describe it one of two ways, I guess. But you're right, a vertical stretch and a horizontal shrink are essentially the same thing for quadratics, and a horizontal stretch and a vertical shrink are the same thing too. But for most people, it's easier just to think of them all as these separate things, depending on how it's written. So that's how we're going to keep talking about it. But I'll give you a little problem to take a look at maybe towards the end here to see how we can pull those two ideas together, though. I'm glad you guys brought that up.
A vertical stretch of 1
Yeah.
and a nothing. That can,
Both would be nothing.
it's going to be a trick question on your test or quiz.
I don't do trick questions. What are you talking about? Anyway, so those are the rules for that. So let's see if we can take a few minutes, and I'm going to give you some combination stuff here. I would like you to do what I ask for each one in the order that I give them, and see if you can kind of build the little equations together here. So all of these are starting with f of x equals x squared. Okay, it's all that parent function for a quadratic. So first one, I'm going to do a vertical stretch 2. So that's going to be number 1, and then number 2, you're going to do a reflection over the x-axis. All right, the second equation you're going to make, you're going to start with translation left 3. Then we're going to do a horizontal shrink by 1/4. All right, well, we'll do 2 more, but let's just start with these 2. I'll give you a chance to just do those. Okay? So just take it one step at a time, all right? And you're just going to rewrite that equation through each step. What happened? What happened? All right, anybody need more time? Yes, sir?
Yeah, no,
What?
I need more time.
You need more time. Okay. All right. I'm going to show you the answers to these here in just a second. Now, if you're curious about how I got to these, please ask, and I will show you. But let's check real quick how we ended up here. All right, so how do we do?
50%.
Got the first one but missed the second one?
Second one, Mr.
Oh, got the second one, missed the first one.
But I thought,
Well, I almost had it.
I don't, for it to be a horizontal shrink, B has to be less than 1, correct? Yeah, but you use the super. Oh, B is greater than 1. I'm a silly dude.
Yeah, you are. All right, so do you want me to show you how I did these? Okay, now I heard someone ask the question. I thought there was supposed to be a couple of equations for each one. If I do that, that's just showing you how I get to this, but this is the final one you should end up with. So with each of these, you start with x squared. And what I was doing on the other side with that one example was I was just kind of stepping through each one. So this is how I would do it, okay? If you have a hard time doing some of this in your head, just do this. All right, so the first thing we're going to do is we're going to take x squared and I'm going to do a vertical stretch of 2 with it. Okay, so now I'm at 2x squared. And then I need to take that and reflect it over the x-axis. So take that whole thing, throw a negative in front. And so this would be the final answer then for that transformation. Does that make sense? Okay, Jason? You had 2 in the parentheses? It's got to be on the outside. Because it's a vertical, so it can't be in the parentheses then. So what you did was a... Oh, it is on the outside? Is the 2 inside the parentheses or outside? 2's inside? Yeah, that's not right then. Because then you would have done a horizontal shrink, technically. Because you just multiplied the x by 2 and not the whole equation by 2. I will show you. All right, so the next one, so we started with x squared again. And then the next step, I had to make it go to the left 3. So everybody with me so far? X plus 3 because we're going left. And then it's a horizontal shrink. But if it's a horizontal shrink of 1/4, technically I'm multiplying not by a fourth, by 4, the reciprocal of that, right? And it's horizontal, so it's just on the x, it's not on the whole equation. So I got f of x equals, replace the x with a 4x plus 3 squared. And then that's the final equation for that one. Oh, yeah, and that's a tricky part of this too. That's a common trap that a lot of people fall into, is that they try to do everything to the inside. Whatever's in the inside, whether it has a plus something or whatever, they multiply to all of it, and it's only x. Every time you do anything horizontal, it's just to the x. Okay? So be careful of that. All right, let's try a couple more. See if we can do 3 things for each one this time. Let's do... Move it to the right 4. Reflect it over the y. And then reflect it over the x. I bet you guys can do that. And then let's do a horizontal stretch 2. Then we're going to make it go down 3. And then reflect over the x. All right, give them a try. See what you can come up with. Once we're done with these 2, then we're going to flip or switch gears and try it the other way. I'll give you an equation and see if you can tell me what happened to it. All right, do we need more time? Some people feeling pretty confident. Oh, come on! I'm recording this, people. All right, I guess that. Hold on. All right. No, we can't do that. All right. So we're back. We are officially recording again now, after the rudely interrupting fire drill. All right. So here's what I have for 3 and 4, so you can check it out. Okay. Number 3 started by going to the right 4, so it's x minus 4 squared. Reflecting over the y made it a negative only on the x, and then reflecting it over the x, I put a negative in front of the whole thing. So, any questions on number 3 then? Yeah? No. Good question. Hey guys, shh. Nope, you cannot distribute a negative inside of a squared because you're, well, squaring it. If you weren't squaring, if it was just a set of parentheses, by all means, go ahead. But you're squaring that stuff. If you think order of operations, if you plugged a number in for x, you'd have to square whatever was in here first before you made it negative. So you can't go ahead and just put the negative in there, because that would be like doing the negative before you squared it, and that's not the correct order of operations for that. So it's got to stay outside. Number 4. Oh, other question? Because it's going to the right 4, and horizontal stuff is opposite of what you would expect, right? So the right is actually minus. Number 4, horizontal stretch of 2. Technically, that's a 1/2, only on the x, right? It's horizontal, it's a stretch, so it's flipped. Down 3, so I took that thing and then minus 3. Now take a look at the last one. Be careful. Reflected over the x, I have negative 1/2 x squared plus 3. That one you can distribute the negative because you're not squaring 3. Okay? So negative 1/2 x squared plus 3. Okay? All right, so let's try. Not yet. I got one more before we do that. I want to do one where I give you the equation and then you guys try to tell me what's going on, and then I'll let you jump into your journals and do some stuff before we get to homework time. So, all right, now I talked about this, how like the order of things matters, okay? So, let's say we've got something like this. That's my quadratic, okay? And I want to know what happened and in what order. So what we're going to attempt to do is we're going to build this equation one step at a time. We're going to build it first, and then we'll go over to the side next to each one of those steps that we used in building it and say what it was that we did to come up with that, okay? So remember, our home base here is just x squared.
Well, how do you tell if it's a horizontal or a vertical?
Based on the way that it's written. If it's outside the parentheses, it's a vertical. If it's inside, it's horizontal. So let's say we just start with x squared, okay? So I want to start manipulating it like to make it look like that. So can somebody give me like a first step I could do? There are lots of correct answers for the first step. Do what? Do a vertical stretch by 3. Okay. Okay, so that would give me 3x squared. Okay.
Plus 5, or
You want to do the
translation left.
you want to do the translation left 5? Okay.
And then you got to reflect it over the x-axis. Put a negative for 3.
Okay, you want to do your reflection next. All right.
And now you got to
And then do the -1 on the end.
done.
All right.
I guarantee that's right. No for a fact.
So let's. Now, like I said, I was just building it here, one step at a time there. But let's quickly describe what we did here with each one of them. Okay. So from step 1 to step 2, what is that? What did we do there? Vertical stretch 3. So that would be, I guess, technically 1, because that's the first thing we did. Vertical stretch 3. Okay. Then what did we do? Which direction is that? We're not reflecting it yet. What did we do next after we did the vertical stretch? Left 5. Oh, yeah, it's a plus, so it's to the left. Okay. Then we multiplied the entire equation by a negative, so what is that?
Reflection.
Reflection over x or y? X. Okay, and then we took that entire equation and put a minus 1 on the end of it. What did we do? Down 1. All right. Okay, so like I said, my recommendation for you would be, when you're doing this, to not just start listing everything kind of willy-nilly, because it matters in how you put it together, what's going on. I'll give you a quick example. What if we had waited to do the reflection until the very end? Okay, so just hang with me for just a second here. What if I took this step right here, where we were at f of x equals 3 times x plus 5 squared. Okay, so let's say I did the down 1 before I did the reflection. Okay, then that would give me this. Right? But what's going to happen if I do my reflection last thing? It's going to turn that into a plus 1, just like this one turned into a plus 3. So if I wanted it to look like this when I was done, this can't be a down 1. What should it have been? Up 1. So if I would have accidentally swapped those two, the order of them, if I did the reflection last thing, I would actually move the thing up and then reflect it. Okay? Well, it's doable. It's just, it's harder to think about, though, because you can't, like, you see the minus 1, you want to write down 1 somewhere on one of your steps. And technically, if you waited for the reflection, you couldn't do that. But it would still be correct. It would just be confusing. So, kind of a rule of thumb with these, if you're going to be doing some kind of a reflection and a movement in the same way, like a vertical movement with a reflection over the x, or a horizontal movement with a reflection over the y, do the reflection first. Always do the reflection before you do the translation. I'll maybe write that down somewhere. Okay? It's kind of a cover your butt thing. You always do the reflection before the translation, and then you don't have to worry about that.
Reflection before the translation.
Yes. As long as it's in the same direction. Like, notice how we did left 5 before we reflected over the x, right? And that was okay, because left 5 is going this way horizontally, and the reflection is going vertically, so who cares? But the down 1 was in the vertical direction, while the reflection over the x was also in the vertical direction, so because those kind of go together, reflect it first, then move it. Okay? Yes, sir? Question? Claypool, question? No? You're just putting the pencil up? Okay. All right, so I'm going to have you guys do a little bit of an investigation in your journals, page 28, I believe. Once we're done with that, then I will let you guys get going on your homework, okay?